Hello everyone, this video is about work, energy, and power past paper questions. This is the last question, so we go backwards from the last question, read the question. On the horizontal floor, here we have car travel along a horizontal road, steady speed, so we can find the first equation. We have the mass, the velocity is constant, so the acceleration is 0, so the engine force must be equal to the resistance force. The engine force equals the engine power divided by the velocity, and the resistance force is just AV plus B. We have one equation in two variables. And now on the slope, we have the mass, we have the engine force, power now 20,000 over speed now 12, and we have the weight component down the slope, W sine, and the friction or resistance force. We have another equation in two variables, so you can just simplify and solve simultaneously. It's a substitution elimination. You'll find the A and the B. Second last question, we read the question. So we have an object on an inclined plane, and at constant speed, so the engine force must be equal to the weight force and the resistance, the friction force. And we are looking for the work done by this engine force. Since this engine force is equal to the W sine plus mu W cos, you can replace the T with this. Work is the force times distance. We can simplify things, plug in, use a calculator, we get the final answer. Next question, we have another inclined plane. We have the mass, constant velocity. Actually, we have acceleration, so not constant velocity, it is decelerated. We have deceleration 0.2, so the W sine and 1800 must be in total bigger than this engine force, which is the power divided by the velocity. So the force in the same direction as acceleration is positive, W sine plus 1800. Wait, there is 1800 here, but it's not written yet. Okay, so we also have the resistance force. I'm just gonna say plus R plus resistance force, equals this. Alright, so this total force down the slope minus this force up the slope equals MA. Plug in everything and solve for P. We get the mega means million, by the way, so 2,060,000 in 3 SF. Next we have speed from 4 seconds to 5.5 seconds, so we have an increase in velocity. So the delta KE must be on the right side because we are gaining kinetic energy here. And we have resistance force, it's got to be on the other side here, on the final side. And on the initial side we have the work done by the man, so this is like the muscle force or the work done by the man, which is say P here. So the work done by the man is 1200 joules. So this is the muscle force times the distance. This is just the work done by the person. We lost this energy and we gain this energy and this energy. Just plug in everything, use a calculator, we get P. Alright, now we have read the question. Find the greatest possible power of the car's engine. So the greatest possible power would be when the velocity is 56, and we have the resistive force 40 V newtons, and the engine force power divided by velocity, constant velocity, so sigma f equals 0, this force equals this force. We can find the P. I greatest 132. Okay, so we have acceleration. The greatest possible acceleration happens when the power is the greatest, so we use the same power. This is the not the value before rounding off, divided by the speed 32. We have the resistive force 40 times the velocity, so sigma f equals ma. We get the acceleration. The car travels down a hill, so this is down a hill, angle theta, speed 50, constant. Find the power. So we have the engine power divided by velocity. We get the engine force. We always have the weight component down the slope, W sine. We have the resistive force 40 times the velocity. So using energy equation here, we have we use sigma f equals 0 actually. Yep, that's it. Constant speed, sigma f equals 0. The force up the slope equals the total forces down the slope, and we can find theta. Alright, last one, read the question. So this B is going down 0.5 meters. This A is going up the slope 0.5 meters. So that means the gain in potential energy. To find that gain, you need to find the height. So the gain in height here is the distance times sine theta, so 0.5 sine theta. So delta PE of B, so this is B losing potential energy, this is turned into, so B's potential energy is turned into A's potential energy because it's getting higher, and both A and B's kinetic energy. They have the same velocity, so we can combine them. So for the B's object B's delta PE, we use 0.5 and the mass 1.6. For object A's gain in PE, we use the mass and the 0.5 sine. The sine theta is 3/5. And for the delta KE, we use the total mass, same velocity. We're looking for the velocity, and we get the final answer. Right, that's it. I'll see you again next time.